Okay. Good morning once again. In our previous class, we looked at event emitters and streams. Am I audible enough? We looked at event emitters and streams. And we also discussed how important they are in NodeJS and how we can possibly apply them. And I believe that was the end of KodeCamp and its design principles. And today we'll be starting TypeScript, and I'm happy. I am happy because after this class, everything will be TypeScript. No more JavaScript, runtime errors, and all of that. Everything will be TypeScript, and I'm happy about that. So let's just begin. We have a lot to cover to do. We will start with the aims and objectives of today. In TypeScript for today, we'll be introducing TypeScript. Then we'll learn about the TypeScript types. We'll learn about type interface, type compatibility, how to combine types, types guards / narrowing, and then last but not the least for today, TypeScript functions, how to type functions and all of that. So you've been hearing about TypeScript. What exactly is TypeScript and how is it useful? Okay, for now, I don't want to bore you with the deep explanation of TypeScript. I just want to briefly introduce TypeScript to you. But as we go on, as we move ahead, like we proceed with TypeScript, you understand how important and what the definition of TypeScript is. Because when you use it and understand its meaning, you derive its definition from there. But for now, TypeScript is just a superset of JavaScript. What it does is it adds features on top of the existing functionalities of JavaScript. So these functionalities, the features it adds are static typing, improvements and maintainability, then the superset of JavaScript. But first of all, the static typing. In contrast to JavaScript's loose typing, TypeScript allows you to define types of variables, functions, and objects or any other types. So to enable the compiler to catch errors early before you even run your code. So that's what the static typing does. It enables the compiler to catch errors before you even run your code. Okay, let's see, for example, let's come over here. Let me create a file, the index.js. So let me zoom in. Let me zoom in a bit. Index.js. Index.js. We have, for instance, we have const do something is equal to, let's say, name. And this is actually a string. Do something is a string. But then if if you try to do something like do something, you try to call it, this will do nothing except if you try to execute this code, you get an error. So node index.js. Okay. Now we have this error here, type error. Do sum is not a function. But if you use TypeScript, let me create index.js file here. So copy this code and bring it over here. Okay. Now we have constitution. Can I include variable do some? This one. Aha, this what this. Can you look at the error here? Let me zoom in again. I think okay, this okay. This is the error I want you to look at. This expression is not callable. Type string has no call signatures. So this is a kind of an example of static typing and static analysis. Because even before you run your code, TypeScript is letting you know that this is not callable. This is just a string and you cannot call it. You understand? This is just basically what static typing entails. But in JavaScript, there's nothing like that. You have to run your code before you discover, oh, this is not a function, so we can't call it. The superset of TypeScript as a superset of JavaScript. Any valid JavaScript code is also valid TypeScript code. So it actually makes it easy to migrate from JavaScript project to TypeScript, or to basically start a new project with TypeScript from scratch, whichever you prefer. Maybe you are building a project in JavaScript that you want to migrate to TypeScript, or you want to build a JavaScript project with TypeScript from scratch. TypeScript will enable you, it will fasten your development process, and it enhances developer experience. This TypeScript also improves maintainability. By explicitly defining types, TypeScript improves code readability and maintainability, especially for larger projects. We also have benefits of using TypeScript. The benefits of using TypeScript include better code refactoring. TypeScript provides a better way and tooling to refactor your code. Also, larger project suitability. For larger projects with multiple developers, TypeScript is suitable for those kind of projects. And improved code clarity. Explicit types makes code easier to understand, and for you that is writing the code and other developers that will also be reading the code. Also, early error detection and all of those. Like what we just did, we detected this error even before we run our code with TypeScript. But with JavaScript, you may get carried away and not detect that error, and then run your code before. That is time consuming, and with TypeScript, you just catch the errors early and make your corrections before running your code. Okay, so under introduction, we've just introduced TypeScript, and we also learned the basic difference between TypeScript and JavaScript. Now let's move over to TypeScript and JavaScript interoperability. So interoperability here simply means coupling different components together, like making different components work together, or bringing different components together to perform a basic, a simple function, or a single function. So TypeScript is fully compatible with JavaScript. TypeScript as a superset, since TypeScript extends JavaScript, any valid JavaScript code is also valid TypeScript code. You just need to add types, and that becomes TypeScript code. You change your extension to TS, which is file extension for TypeScript, and then you add types to your code, and that is valid TypeScript code. So it allows you to gradually introduce TypeScript into your existing JavaScript project without rewriting everything at once. also using JavaScript libraries. You can seamlessly use existing JavaScript libraries in your TypeScript projects. So there are two ways to do this. So the two approaches to this is one, direct inclusion and type definitions. So you simply include the JavaScript files directly in your TypeScript project. However, this approach won't benefit from type checking for the library functions because you just directly include your JavaScript code in your TypeScript, so it won't check for types because your JavaScript code is not typed. But then the second approach is type definitions. For better type checking, you can leverage existing type definition files with the extension of .d.ts. The D is for declaration, the .ts files. They provide types information for popular JavaScript libraries. So these files basically help TypeScript compiler understand the expected behavior of library functions and variables. So in using TypeScript code in JavaScript, first of all, there are processes you follow to use the TypeScript code in JavaScript. The first step is to compile TypeScript to JavaScript. That's not actually the first step, but you already know how to create your file, write your code, and then you compile TypeScript to JavaScript before you can run it, before Node can be able to understand, or any browser can be able to understand the code. Because TypeScript only helps in checking types and other advantages like fostering developer experience and making sure you are writing correct code, because JavaScript is is loose, it's statically loose. So TypeScript enable you write correct code without having to go into debugging always. So the first step is for you to TypeScript code needs to be compiled into plain JavaScript before it can be run in JavaScript environment. So moving on, we have running TypeScript. How do we run TypeScript code? The first option is TSC, which is TypeScript compiler. And the second option is tsnode, which is it's a kind of library built to run TypeScript code on the fly. That is, it compiles and then runs the JavaScript on the fly without having to compile first, then run the JavaScript in the second step. tsnode just compiles your code and then outputs the results immediately. And then the TS playground. For learning purposes, this is the third option will be the one we'll be using, but then we'll have to go over the first option to understand what it means and how it works. The second option as well, and then the third option is where we continue with, because we don't have to write files and then run the terminal always. We just use the playground, the TypeScript playground. So without wasting much time, let's continue with TSC. So if you have TypeScript installed on your machine, you already have TSC installed. So I think TypeScript, TSC. I already have TypeScript installed. Okay, I already have TypeScript installed. So if you don't have TypeScript installed, first of all, you need Node. I believe we all have NodeJS installed on our machines. So if you don't have TypeScript installed, you can go ahead and do that. If you are on Windows, you can just, and you are using npm, you can just run npm install -g TypeScript like this. But if you are on a Mac, you will have to use sudo npm install G TypeScript, like so. You install TypeScript globally on your machine so you can access it anywhere. But if you want to install TypeScript only in your project, you can simply run npm. You can install it as a development dependency by saying that save the TypeScript, or you can install it since we are not going to production. You can say npm install TypeScript like this. I already have TypeScript installed, but I'm on a Mac, so I'll do something like sudo npm install -g TypeScript, and then I'll enter my password, hit enter, and TypeScript will be installed globally. If you're on Linux, you use a Linux command. What is a Linux command again? Is it I've actually forgotten, but you can actually check it out, because I don't always work with Linux themselves. I've actually forgotten the command. Is it is the app you have to first of all update the registry and then install. That's just it. If I'm in Linux, you just check out the commands. It's easy to check them. Then after installing TypeScript, you create a TypeScript file. Now we've installed TypeScript globally. So this is our TypeScript file. Let's see, const name. Let's see, const person is equal to person. Let's see, we just want to return the person name is equal to, let's say, KodeCamp, like this. So this is actually a string. Then we say log, not local storage, log person. Now let's run npx tsc. Okay, now let's open here. Now it has provided us with options. These are all the options you can use with TSC. TSC help all, TSCP to show the path, TSC inits, TSCB, TSC add duties, whatsoever you want to do with TSC. And the version of TypeScript here is version 5.4.5. Okay, so now what we want to do is to actually run this index.ts file. So npx tsc index.ts. Now, if you check our index.js file, we actually have this code. This is our TypeScript file. So let's delete this index.js file. Actually see what's happening. So let's run it again. npx TypeScript compile. What we are saying is TypeScript should compile this index.ts file into JavaScript. So let's run it once more. And now we have a JavaScript file. Now we've compiled our TypeScript code into JavaScript. Now let's look at what is inside. Okay, so we have, this is basically TS5. And when we start working with tsconfig.js, the config file, we see how we can specify the output JavaScript versions that we want and all of that. So we've compiled our code, and in JavaScript, this is basically how we write our code. Okay, and you can even specify the target. You can say -- target is equal to, you can say ES5 or ES2015 or ES3. But we don't need to do that. Now we've learned how to use TSC to compile our code. Now we can even come here and say, let's write a function of let's say get name. This function takes a name of a string and it returns a string. Then we say return name. Down here we say log get name KodeCamp. And now that we want this function to return a name, and the name is a string, let's pass in a number and see what we've got. So 6. Now, you've got an error here. Hover over it, and you see, okay, let me just move this down a bit. If you hover over this number, you see argument of type number is not assignable to parameter of type string. So TypeScript is letting you know that, oh, you're making a mistake. You specified a string here, and now you are providing an argument of a number, which is not correct. So we just have to provide KodeCamp. And in here, if you don't provide any argument, you still get an error. Argument for name was not provided. TypeScript is letting you know that you must provide an argument because this is not optional. And if you want to get away with this error, you can make this optional like this. And then this here, type string or undefined is not assignable to type of string. You are trying to return name, and what if you don't pass in this name? TypeScript let you know, oh, this can be done. So what you basically do is just do something like KodeCamp, and this error will go away. So this is how TypeScript will save our lives. You don't have to think too much, just write your code and TypeScript will point out things to you that you need to do for your code to be correct. Now, if you remove this optional operator here, and then you get your own error here, this way you pass in your KodeCamp as argument. So now let's compile our code, npx ts TypeScript compile index ts. Okay, it's done compiling. Now let's open our index.js file and see what we've got. Now we've got our function get name, and then we see that our JavaScript is here. Now we can write node index.js and we have KodeCamp. But every time we do this, let's assume every time we make a change here, let's say we change this to code. Every time we make this change, we have to come here and type npx ts c index ts. It will compile our code that the changes will reflect here, and then we have to come here and write node index.js again to see the changes. So that is where ts node comes in. And what is ts node? Let's head over to ts node docs and see what ts node is actually. This is ts node. So ts node here, let me zoom in a bit. Ts node is a TypeScript execution engine and a REPL for NodeJS. So read, evaluate, zip print, and that's it. So it's a just in time. JIT here means just in time. It's just in time transform TypeScript into JavaScript, enabling you to directly execute TypeScript on Node.js without pre-compiling. So this is accomplished by hooking Node's module loading APIs, enabling it to be used seamlessly alongside other Node.js tools and libraries. So these are the features: automatic source map in stack traces, automatic tsconfig JSON parsing, automatic defaults to all of that. So this is how we can install ts node. We already have TypeScript installed, so we can come over here and see npm I. We install it as a development dependency ts node. Now, after installing ts node, okay, so we now have ts node installed. So we can just go ahead and use ts node. You can see npx ts node index ts. Now that we have ts node installed, you don't have to pre-compile your code before running the JavaScript version. Now I run npx ts node compile this and then run it. That is what TS Node is doing for us. It just works as Node.js, the Node command, Node index.js, but this one is different. TS Node index TS. And if you have TS Node installed globally, you can just say TS Node index TS. But I don't have that installed globally, so it's installed locally in my project. So I just have to use npx to just execute this because it is installed just in my project here. npx TS Node index TS, and then we have our code. We don't have to precompile it to JavaScript first. Now, if we make our changes here, KodeCamp, we just run npx TS Node index TS, and we have KodeCamp. And we are just running this code. We are not precompiling. We are not outputting it in our index.js file. So how do we precompile our code and then run it at the same time? We've learned how to use TSC. We've learned how to use TS Node. And mind you, TS Node is using TSC under the hood with added functionalities to perform that function, to just compile your TypeScript code and then output it. So we can also use the TypeScript playground. So where is the TypeScript playground? I've already opened the TypeScript playground, but you can go to, let's just type TypeScript here, open TypeScript, and you have, look at the playground and all of that. You can click on the TypeScript link here, and you come to their their landing page on their official website, and you click on the playground. Look at the playground here. Let me just move this up. Okay, look at the playground. Just click on the playground, and then it will take you to the playground, and it will download TypeScript and all of that. So we learn how to use the playground. I already have it open. Let me just close this one and come back to this playground. And in this playground here, you see something like use strict. And what is use strict? We will talk about the use strict in a minute. Let's just see how to use this playground. So you can just type something like, let's say person name is equal to KodeCamp. And you immediately see your result here. This is your JavaScript code. Now you come down here and see console log p name like this, and you've seen it. Now, if you click on this d.ts, this is the type definition for this JavaScript file. This is the definition.typescript, the definition file. This is the type definition for this. So we don't have any errors. This is the log. So if you run this code, you click on this run button here, and then this code will compile. And on the logs, here we have no errors, and in logs we have KodeCamp because we are logging this KodeCamp on the console. And the plugins used in this playground, we have the transformer timeline, presentation mode, third-party plugins. We have Prettier, we have format on C, DT review, and other plugins. But this is the equivalent JavaScript code to this TypeScript. So you can go ahead and write the function of get name that takes in a name of string and return a string. In here you see return name. Now if you see return, instead of you make a mistake and TypeScript cannot find name this. So because you are returning this and this here is different, but JavaScript will never let you know that name like this. And down here you can see console, let's confirm, console log get name, and you pass in KodeCamp as an argument like this. So this is the equivalent of JavaScript code to this TypeScript. And here you already know what use strict, what the use strict directive does in JavaScript. So this is ensuring that your code is running in strict mode in JavaScript. So if you open this here, this is the type declaration for this function. This function takes in an argument of okay, I initially asked if I'm audible enough. Okay, can you hear me now? Okay, I believe you can hear me now. Okay, so this is the type declaration file for this function. So the declaration, this function, the name here is get name. It takes in the name and returns the name, and the name here is a string. So it takes in the parameter of a string and returns a string. So there are no errors, and on the logs, if you run this, you also have KodeCamp. So that's basically how to use this. And when we get to the compiler options and other options, we look at the TS config and how to set all the compiler options in our VS Code and using the TS playground. So we get to understand it better. And now moving on, we've basically learned how to use the TS playground. So installation and configuration. Now that we have TS Node installed, we configure our TS config JC. So this file, the TS config file, basically holds the configuration for our project. It basically holds the configuration for our project. So all your configurations will be in this file. So how you can create a TS config file, you can basically come here in the directory of your project and then create a TS config file. Or what you do is say npx tsc -- initiate. And once you run this command, just be observing, take a look at this sidebar. If I run this command, you will see a TS config JSON file created. Now, if you open this TS config file, let me now close the sidebar. It holds our project configurations. This is the compiler options, the target. Now, the default other options are commented out because they think these are the basic ones we need in our projects, and then we can go ahead and then configure the remaining ones by ourselves. Okay, so now these are the compiler options and every other thing we need to know. But first of all, we have to look at the ones they leave for us. Now we have this skip live check, skip type checking all the DTS files. If you enable this skip live check, you are skipping the type checking for this file, the DTS file. And there's another option here, strict. Let's talk about the strict first. In the strict, let me come over here, open TypeScript. And in this TS config JSON file, the strict is on. And this time around, let me run npx tsc index TS. Okay, our code is compiled. Now open the index. Okay. Okay, our code is compiled, but the strict mode is on. Now I want to remove this string here. It is inferred. Now, if you hover over this function, you see that it's returning a string because it is inferred. And we'll learn about type inference later on in this class. Now, if you remove this one here, you get an error. If you hover over this, you have parameter name implicitly has an any type. And once it has an any type, if you pass in any here, then you can pass in, and if you pass in a number, an argument of 6, there will be no error because the parameter can be of any type. It can be an object, an array of anything, but that is not what we want. So if you remove this thing, this any, you have an error because it implicitly has any type here. Now, if you hover over this, you have any and returns any. So if you go over to your TS config JC file and turn this strict mode to false and save your file, come back to your index TS file, this error is gone. You just have these three dots underneath your parameter here. And if you hover over it, it is telling you that this has an any type to make you understand that, okay, this has an any type. So just specify your type here, but it is no longer a strict mode. Now your strict mode is turned false. So your TypeScript, the type checking is no longer a strict mode. It allows you to check your types anyhow you want. And all these configuration options are there for you to configure your project the way you want. If you want strict type checking, or if you want to just loose type checking, or anyhow you want it. But that is basically it. Okay, so moving on, let's move over to I want to first of all introduce the basic ones before moving over to the rest. And the module type to use here is common JS. You can change it to ES modules. But when your code is compiled, what JavaScript module do you want to use? Here it is common JS. And in order to verify this, let's create another, let's say, util TS. And you see, let's move over to the index TS, then copy this file, bring it over to the util TS. Bring it over to the util TS. Paste it here. Do away with this. And then let's go over to TS config file and turn this strict to true. Let's turn it to true. Come over to index TS. Make this a string. And then we simply export this function. Not here, not here. Okay. Let's do away with this. Export this function. Change this one here to string. And in our index.ts file, we will import, you can hit command spacebar, no, not command, control spacebar, and this will be imported for you. And change this to code. Now, let's compile our code, npx.ts, index.ts. Okay, now we have both util.js and index.js. Now you can look at what is happening. There's a use strict directive here. There's a use strict directive. Now, because the strict mode is on, it's directing our JavaScript file to execute in strict mode. Now, when you look at your util.js, look at how this is interpreted. Export get name is equal to void 0. Initially, the object export is holding this name that is returning nothing. And this is ES5. And I don't want to go over explaining this code because our TypeScript is compiled to ES5 and it is using modules, common JS modules, not ES modules. Now, if you go back to our TS config file here, and we will look for oops, I can't seem to find it. Common JS and no live check. Targets. You can look for target and change this to ES 2016 or let's change it to EX 2016. And then let's go ahead and compile our code once more. Okay, this time around, let's check our util.js. Nope, we're still using common JS here. Did I save the file? Okay, yes, 216 common JS You can change here to ES6 and then compile this code once more. Let's clear up this. Come over here. So we should be able to get our results properly. Oh, I'm still getting the same result. Okay, so what is happening here? Let's undo this first. Okay, strict true. I just want to show you these options, how we can change these options to, because ES5 is TypeScript is compiling our code so it can be able to work with backward compatibility to support backward compatibility, like browsers that cannot handle ES6 and all of that. So I'm looking for the output directory as well. Output directory. There's an output directory here. Base URL root directory. And this is going to take much of our time. This is going to take much of our time. Let's just, after this one, we'll move to something else. I'm looking for the output directory. Check.js, allow.js. This allow.js, this one is to enable us allow JavaScript files in our project. But if you turn this to false, if you declare a JavaScript file in your TypeScript project, you will get an error and you won't be able to use it. This one will allow JavaScript project in our TypeScript project. Okay, so there's an output directory. Okay, okay, look at it here. Our output directory should be in the dist. Then let's uncomment this. And then let's run this once more. Okay, so our code is run and there's no output directory is dist. Let's delete this here, delete this one. The npx tsc. Okay, so we'll just run npx tsc. Okay, so that was a mistake I was making. I was running npx tsc index ts. So now we have our dist and we have our util.js here and our index.js here as well. So we just run npx tsc and it will look at our project directory and then compile our code for us. Now, if you come to our app and change this to build, this means distributable, the one that you can distribute for platforms to run. Now, if you change this to build and then run your code once more, you will see that you have a build folder here with your index and util.js. Now, this time around, we have our build. Let's delete the dist. Oops, not rename. Okay, let's leave it there. Come down to our tsconfig file here, and then change this to strict to false. We change strict to false, and then come over here and change one more thing. Change this to target. Yes. Change this to yes 2016, like this, and then run our project npx tsc to compile our code. This time around, check our build. Okay, our build is still the same. Did I change this to? That's basically it. Those are the basic options. Okay, so those are the basic options for tsconfig file, and we've looked at the compiler options. So moving forward, TypeScript types. So we've looked at how basically you can configure our tsconfig file. And as we move on, we'll learn how to enable and then use all those compiler options effectively. But for now, let's just focus on the TypeScript types. First of all, we have the primitive types. We look at the primitive types, the object types, other types, the assertions, type inference, and type compatibility. Okay, so we all know what primitive types are. Primitive types are they represent the most basic building blocks for data in any programming language. We have the number, the string, the Boolean, the null and undefined, and that is in JavaScript and all of that. So we start with the string. And as I earlier mentioned, we'll be using the online playground. So for the string, we basically have for the string, you can go ahead and do something like person name is equal to, this is a string code like this. So once you do this, you will see your equivalent TypeScript code. Now let's go to, this is our tsconfig file. Now we can go ahead and turn this off. If you turn the declaration option off, you will no longer, if you save this and you come here, you will no longer see the type declaration for this. But if you turn it on, and save your file, you will see the declaration, type declaration for this code. Then you can go ahead. Now, when you look at your JavaScript equivalent to the TypeScript code, you see use strict because your code is now running in strict mode. Okay, so now let's go ahead and then change this to turn off strict. If you turn off strict and run your code, okay. Oops. Now, if you come here, turn off strict, and there's also another option to turn off. Strict not check strict function type. Always strict. Now, if you remove this always strict and remove the strict mode, this use strict is gone. So you are no longer running your code in strict mode. Now there's no longer use strict. This JavaScript code is no longer running in strict mode. So you can come over here and then change it back to change the always strict to true, and then you see your use strict directive here. And you have other options, no implicit any. This no implicit any, the strict mode enables all these options, the strict function types, the strict. Now, if you uncheck all these options here, uncheck all of these, then come over here and check strict mode. Then all these options are enabled. Once you check the strict mode, all these options are enabled. No implicit any is enabled. Strict not checked is enabled. All these are enabled because you are running your type. The type checking is in strict mode. So that is basically just the type component, and you can change this target here to ES5. And once you change it to ES5, now ES5 uses var. There was no let or const in ES5, so it uses var. That's the reason why once you change it to ES5, you see var pname is equal to code. And then the module here is ESNext. You can change the mode to CommonJS, ES215, ES2020, ES2022, and all of that. So if you change this one here to ES3, you see var, because ES3 and ES5 uses var. If you change it to ES215, you have your const as specified. The language is TypeScript. not JavaScript. Okay, so that is basically the TS config options, and this is the string. And in terms of number, the number primitive type is here number, and since this is a string, you have an error. The error here is basically saying const pname number is not assignable to a string. Now, if you hover over this, you see that type string is not assignable to type number. Then if you change this to Boolean, let's just change this to 2, and we have our error go away. Now our error, we no longer see an error because this is a number and we have a number. So if you change this to a Boolean, and then you see an error, type number is not assignable to type Boolean. And you can change this to true, or basically false, and you are good to go. By the time you specify this to a Boolean, or we look at combining types later in this class. We can combine types Boolean or number. Now you can say let pname equal to false, and then you can come over here and say pname is equal to 2, and you don't have any errors because this can either be a Boolean or a number, but not a string. By the time you assign this a string, you get an error. Now this error is saying type code is not assignable to type number or Boolean. Okay. Okay, so moving on. The primitive types, we've looked at the string, the number, and the Boolean. So what about the symbol? And we also have the symbol, the null and undefined, and we also have the void. Anthony, we'll come to that. We'll come to type inference. Basically, we are just learning, so we have to learn properly. But we'll come to type inference in just a bit. But for now, we are learning, so let's continue this way. Now we have, while using the online playground, so we also have symbols. You see, const p symbol is equal to symbol, let's say person. And this doesn't have any static. If you hover over this, you see the symbol constructor takes in the description of a string, number, or undefined, and it returns a symbol. So this basically doesn't need a static typing. If you hover over this symbol here, you see that it is type of a symbol. It is type of this, and the type here is this. So you don't need to basically do that. But for now, if you want your value, let's say let number equal to either string or null, and you see let number equal to number or null, then you see 20 like this. It should be like this. Then you have 20. Now, or you can leave it like this. You can say equal to null. At first, number is null. That is to ensure your code is written. This is the one of the best practices in coding. At first, if you don't just declare, let's say you have let number 2 and then leave it like this. Because if you hover over this, you have a type of any, and any type can be assigned to this. So you have to do away with that. Number equal to number or null. Then you assign it to null. Then later you want to assign a value to this. You cannot say number is equal to code. You get an error because you already specified the type here. So it can only be null or number. You can say number is equal to 2, and later on you can say number is equal to null to enable garbage collection. So to free memory to free some space in memory like this. Okay, as of undefined, if you say let number and you leave it like this, if you hover over this, initially you have number here, you can say number is equal to 2. Then you can say number is equal to undefined. Now you have an error here. Undefined is not assignable to type number. You can say or undefined. And then you can leave it like that. Then later you can assign it to undefined or, but what this is happening here, if you say let number and you assign nothing to this number, initially this number is undefined, even if it is a type of number, because no value is being assigned to this number. Okay, so now we've seen how we can specify number types, undefined and null. Moving on, we also have the void. So the void is not a primitive type, but rather it is a special type that signifies the absence of meaningful return in a function. Let's say you have a function print name that takes in the name of the string, and then what it does, it returns nothing. Void here means it returns nothing. So console. So if you specify the return type of void and you say return name, you get an error. What type string is not assignable to type void. Okay, what TypeScript is trying to tell us that, oh, so what you are telling us here is you don't want to return anything, then why are you trying to return this name? That is not possible. So you can't return anything. So what we do here, we simply say log console log name. So this function doesn't bother about returning anything. So if you run your function, say print name, and then you put in code as an argument. If you view your logs, you have code here, but it doesn't return anything. If you try to return something, you can specify this, okay, return like this. You know what this means? It returns nothing. This is the same thing as void. But if you say return a value, you get an error. This error is in string is not assignable to type void because you cannot return anything in this function because the return value here is void. Okay, so that is basically for the primitive types. And then the object types, we have the interfaces, we have classes, and we have other types as well. So for interfaces, if you want to interface, what they do is they act as blueprints for defining the structure of objects. So they specify the properties and optional methods an object must adhere to. So they also promote code reusability and maintainability and all of that. So let's assume you have an interface, let's say user. They always start with capital letters here. And in here, you have your properties and method. The name must be of string. And the age must be of a number. We have a method here that must be of a function, have greet. And this method will take in argument of message, which will be a string, and it will return the message, which will be type of string as well. So now if you open your JS file, there's nothing there because this is type and this is only useful in TypeScript, not JavaScript. So it is not compiled, there's nothing here. But we want to implement this user, this interface. So if you want to implement it on a class, you can just go ahead and say class, and then you can see, let's say customer implement, you want to implement this interface on this class, user. Now, this class must adhere to this interface. So what you will do here, you see the name is string, and the age number, like this. Okay, like this. and you have your constructor. The constructor function here is constructor. Okay, let's do away with this. Okay. Okay, it's missing. Okay. Name, string, age, number, and greet, message, string, string. Now, in this constructor will take in a name or string, age, number, and what will happen in the constructor is this name equal to name, and this age equal to age, like this. Okay, so we're still getting an error here. Greet is declared here. Okay, so we're still getting this error because if we mark this as optional, not there. Okay, we can mark greet as optional. If you mark greet as optional, this error will kindly go away. But now that we've not marked greet as optional, we can come down here and see greet, and then greet will take in a message or string, and this is a method, so it will return a string, and then we can see in here return hello message, hello message, like this. And now we've successfully used this interface on this constructor here. So if you comment this out, you still see an error here. So the customer incorrectly implement interface user type customer is missing the following properties. So you first of all, if you implement the user on this, you have to comment this. Now our interface is correctly used here. Now, if you make this optional here, and then you come here and then remove this, as well remove this, you won't get any error because the age is marked optional. So there's no errors. That's how to make properties optional in classes. So we've used this interface here to implement our class. So the interface defines what an object should look like. So this interface here defines what a user should look like. A user should have a name, age, and a greet method as well. And then classes can implement interfaces, ensuring they provide the required properties and methods. So what you can basically do is, without implementing this interface, without implementing this user interface here, you can come here, remove this, implement, and then do away with the interface. And we still have our class intact. You know, look at the equivalent code in JavaScript. You have the class, the constructor, and the method. But here in TypeScript, you have to specify the name, the age, so we can correctly use it in our constructor in order to avoid errors. Now, if you come here and try to say new customer is equal to new customer, and you pass in 2 and pass in code, you get an error. Look at the error. The error is saying argument of type number is not assignable to parameter of type string. So you have to change this here to code and 2, like this. And your class works as expected. Now you can see new, then you can call if you call the age, you can print the age, basically. But if you call it, you get an error. The expression is not callable. So this is what TypeScript is doing for us. It's statically checking the types of, but you can now call the greet method. Then you can pass in the message. If you don't pass in the message, you still get an error. And the error here is an argument for message was not provided. Then if you mark this as optional, this error goes away. But if you remove this and then provide, let's see, okay, let's see, morning, like this, and you run your code, you see your result. Logs, okay, we're supposed to just use a console log here, like so. Okay, now we run our code and we have hello morning, or okay, let's say KodeCamp. That's basically it for classes. So this is how to basically use, these are the class types, how to type classes and all of that. So the other types, we have the any type, we have the object type, and we have the unknown type as well. We have the never type as well. And we'll look at this briefly. Let's first of all look at the any type. Any can be of any type. You see, as we earlier said, function, we take in name of any and return any. You say return name. Okay, function get name, the name of the function. Then you can see console log get name. And then you can pass in a number. And it doesn't care because you specify the type of any. And if you run your code, here, you have 2. If you pass in a string code, you run your code, you have a string because this is of type any. So any means any type. Okay, so apart from the any type, we also have the object type. Let's assume the data you want to take in is object. It basically represents a generic object type encompassing any object in your code base. So, it is less strict than specific object types, but still offers some type checking. So when you need to interact with an object, but its exact structure is unknown or flexible, you can just use the object type. And it acts as a base type for interfaces or classes that inherit common properties. Okay, so we're using the object type. You can do something like, let's see, function person, and then here you have P of object type. And what it does is you can specify the type you want to return, or you can leave it and it will be inferred. Now you will say if name in P return P dot name, like this. Now if you hover over this, you get an error. Not all call path returns a value. You say return no name. Simply return no name. So in object, you want to check if a value is in an object, you can use this in operator here. So if you want to pass in an object to this person, you can say console log person. Then you pass in an object of name code, like this. And then you run your code and you have code. But if you don't pass in this, you run it and you have no name. So it first of all check if name is. So what this expect is it expect an object. So if you come here and pass a string, it will throw an error and say Argument of type string is not assignable to type parameter of type object. So this is basically the object type. It takes in an object, and in here you can pass an object with multiple keys and values. You have name, code, and age 4, like this. And this still works. You can pass an object with multiple keys and values, and it will still work as expected. So we have the unknown type. The unknown type is important where you don't know what value will be returned. So it basically represents a type that holds an unknown value at compile time. And it was introduced in TypeScript 3.0 for better handling of dynamic data. It is used as a function parameter type when the function expects a value of unknown type. And it's also used as a return type for functions that might return different data types at runtime. Let's assume we have a fetch function. Let's see function fetch data that takes in a URL, which is a string, URL of a string, and return unknown. And then we fetch data. A function whose declared type is neither undefined, void, nor must return a value. Okay, they are also return some. Because we don't know what we are returning, we can return a string. We don't know the type of data the function will be returning. It may be an array of names, a string, or a boolean. So we don't know. So anything that is returned in this fetch function will be handled perfectly. So that is how the unknown type is used. And the never as well. We also have the never type. And the never type represents a type that has no possible values. It's often used in function return types to indicate the function never returns normally. Let's say we can do an error. And you can see function error, message, string, never. You see throw new error message. Okay, so throw new error message like this. Then we can say error. Oops. Like this. And if you run this code, what you are seeing here is error, executed JavaScript failed. And what you are seeing here is an error. Oops. It throws an error and never returns anything. Okay. So that is basically how the never type works. And moving on, we have enumerations in other types. We have enumerations, we have arrays, and we have tuples. So in enumerations, enumerations that are just a set of named constants representing specific values. So they are not mutable at runtime. Like they improve readability and maintainability compared to using raw numbers. So let's see how we can use the enum type. You can see enum colors. And in here you have, let's see, red equal to 1, blue equal to 2, green equal to 3, like this. And then you can come here and see, let favorite color equal to, you want to use the colors type, and this is equal to colors dot green. This is your favorite color. So you can see console log favorite color. So if you run this, you have 3 as your favorite color. So you've enumerated your colors, red, blue, green, and all of that. Then you can, if you try to access something like this, you have an error here. Green does not exist on type of colors. So green does not exist in the enumerations you've just declared. They also have arrays. We have an array of numbers. Let nums equal to 1, 2, 3, 4. And then you come here, numbers, but this time around, it's an array of numbers, not just numbers. So if you change this here to code, and then you get an error. The error here says string is not assignable to type number, because this is an array of numbers, and what you have here is a string. So you just have to do away with this, like this. So this is the type for arrays. What you want your array to hold. Now here, your array is holding only numbers. So you cannot specify, you cannot add any other type to that array except numbers. Then if you change this to, let's say, string, you get an error here, except you come here and then change this to, let's say, code. And then your code is compiled successfully. And here we have our array of strings. So you can add another one, camp, and we have an array of strings. Okay, so this is basically how arrays are typed. Notice this, the bracket, the square brackets in front. And then moving on, we have tuples. What are tuples? You can specify a fixed length of array. So tuples are a fixed length of array where each element has a specific type. So it provides strong type safety for arrays with a predefined structure. So like what we earlier did, if we change this to a number now, so let me just make this a one liner. If you change this to a number now, we have an error. What this error is basically saying is type number is not assignable to type string. So we have to come in here and then see the first one is a string and the second one is a number like this. Okay, and then we do away with this here. And then our code runs as expected. And in our JavaScript code, we have an array of a string and a number. Here, we are just telling this, we have an array, but this array should contain the first element of this array should be a string, and the second element should be a number, basically how we want it to be. So that is basically how a tuple works. And you cannot mutate tuples. If you try to change the first element of a tuple, you get an error. You see, 0 is equal to, or let's say change it to 2. Now you get an error. Number is not assignable to type string. And also, if you change it to a string, let's say count, and you run this code, you get an error at compile time. Now let's move over to assertions. Those are basically arrays and tuples. So move over to assertions. Under assertions, we can assert as const, we can assert as any type, and we can assert as any or any type at all. So asserting assertions here basically primarily used with arrays and objects to make them immutable. So if you mark an array as a const, it is not mutable. You cannot mutate it. But if you mark an object as a const, you cannot mutate it. Or as any type, you can say this is as this. Okay, so let's see how we can assert arrays. See, as const. So if you try to mutate this nums 0 is equal to 3, now you get an error. Cannot assign to 0 because it is a read-only property. So you cannot mutate this. But if you say as let, now this can be, and it will even throw an error. Let is not reserved word in strict mode. It's a reserved word in strict mode. Now you can do away with this. It's the same thing as saying as let. And say as const like this. And then you have an error here because you cannot mutate this because it is a constant array. And same thing with objects. Like this. One, two. Like this. And then you can see as const like this. And then you can't mutate this. You can see nums and then see okay, numbers dot 1, or you can see numbers dot 1 is equal to 1 is equal to 2. You can't mutate this. If you come over here, you can see constant one because it's a read-only property. You can't mutate this object. So you can basically, as this as here is an assertion. You are asserting this to become a constant. So you can say items. Let's see. You can declare an array of items that holds any value. You can see const items is equal to 1 through code. And here you can see n, because even if you don't specify this as an array of any items, it's already inferred. Now it's holding string booleans and numbers. So you can see const array items is equal to items as string, like so. And now if you hover over this will only hold this is as any, but this now is an array of string. Now let's see what we've got. Array items. Now if you run your code, you have 1 through. We're saying this should be converted to an array of strings. Basically here is an array of any type. And what we're having here, we're having through code 1. But if you, let's log type of array items 0. Okay, so it's outputting a number, but this is a weird behavior. But this item says as string. Okay, TypeScript sometimes is tricky. Okay, this may cause an error if the type doesn't match. It casts an array of strings, but here we are not seeing any. Okay. Is this strict turned on, or strict is on? Okay, so basically that's it. I don't know why TypeScript is not showing an error there. And then we have null. we have the null assertion, the non-null assertion. You can see on string is equal to, this is basically this is a string or null. Then you can say console log string, like so. Now, if you run this, we should see code. But in some cases, let's say we have an object of names where something is optional. Let's say we have an object. We have const names is equal to okay, so in this object, the name is optional and the age is required. Now we can see console log, we'll say names dot name. And now here in actual code, the name may be a string or undefined. So if you do away with this, now this, you don't know if the name exists or not. Now, if you run this, what you are seeing here is undefined. So here, this is not throwing any error, but it's supposed to change this to like this. So that if the name is undefined, it should just return undefined. But in a case where you know that the name exists, let's say you have the name here, then you can do something like this. Yes, I am sure that this name exists and it will not print undefined. So do not throw any errors. So then if you run this, you have code here. So that is the use for that. In a case where you have something is optional, or you know that yes, the value is provided. So you want to tell TypeScript that yeah, I know this value is provided. So there's no need for any checks or all of that. Okay, so there are other keywords like the satisfies keyword, where you declare a type and check if it satisfies a condition, and the checking for truthiness and strictness and all of that. So you can actually reference the docs. There are some minor things you can check in the docs and then get to understand. But moving on, we have type compatibility. Type compatibility. So under type compatibility, type inference first. Type inference before type compatibility. So type inference is just a simple thing. There are some simple types that TypeScript already know what they are, so you don't have to specify the types. So basically here, if you come to this const person name is equal to code, and then if you hover over this is a string, okay, but it's not I want something that will show here, because if you hover this, it's supposed to show you this is a string. So you can see, okay, const. Okay, let me show you a basic example of, let's say, this function get name string. Now we've specified the parameter type, which is a string, but we did not specify the return type here. Now, if you hover over this function, it is inferred. The return type is a string, because once you specify the parameter type and there are no other operations in this function, the TypeScript already knows that, okay, since the parameter is a string, once you are returning the name and the name is a string, you are basically returning a string. So the type is being inferred. So that is type inference. Type is inferred, and you don't need to come here and explicitly specify string like this. This is not necessary because TypeScript already knows that, oh, what you're returning is a string. So this is basically type inference. The type is inferred automatically. So TypeScript detects that. This is very, very useful. So type compatibility determines whether a value of one type can be used in a context that expects a different type. It's basically a core concept that ensures that type safety and it ensures type safety and prevents core errors during compilation. So there are principles behind it. The structural typing, the assignment compatibility, and the rest of that. So TypeScript uses structural typing, meaning compatibility is based on the structure, that is the properties and the method of the types, not just their names. Then in assignment compatibility, a type is considered assignable to, like a type A is considered assignable to type B if a value of type A can be assigned to a value of type B without causing a type error. So that is basically type compatibility. So our factors affecting compatibility are the send types, the subtypes, interfaces and classes, and all of that. So the most basic case to identifying same types is you cannot assign a string to a number. A string and a string are fully compatible, okay? So you can assign a string to a string, but you cannot assign a string to a number. What about a subtype? A subtype inherits all the properties and method of its supertype. So a value of a subtype can be assignable to a value of its supertype, e.g. Let's say, for example, a number is a subtype of any. So a number can be assigned to any variable. But it's not advisable to always use any. In fact, do not use any in your code at all, except where necessary. So you can go ahead and check out type compatibility and how it helps in TypeScript, and to avoid types that are not cannot be assigned to other types and all of that. So now that we understand the basic TypeScript types and all the primitive types, object types, and other types, we've briefly looked at them. Let's move on to combining types. So under combining types, we have the union types, we have the intersection types, and we have the type aliases. We also have the key-off operator, and basically that's it. We have the union types, intersection types, type aliases, and key-off operator. So the union types, as we earlier mentioned, it's something we've done. You can see pressing. It's either pressing, we can see string. This or operator here is used for union in TypeScript. It can be a string or number. You can say it's equal to 2. And then later on, you can reassign this to a string like this. Okay, this is a const. Let's change it to let. You can reassign it to a string and it won't cause any errors because we are combining types. The type can be a string or a number. And you can basically use this in a function where you want a function to get something that can be, the name can be of a string. This is just an example. A name cannot be a number or number, and then like this. So you can pass in a string or a number as an argument to this function. And then in the return type, you can also say this can return a string or number. So you say return name. Now, if you hover over this function, it accepts argument of string and number. It also returns a string or number, basically. Okay, so moving on, that is basically union. So intersection, the AND operator is used for intersection. You can see interface user. You can see name. Name is a string. Then you can say define another interface. You can see admin. Then you can permissions. Permissions here can be an array of strings. Array like this. And when it comes to a user admin, you can say type user admin equal to user and admin, like this. So this intersection, then you can say let's combine equal to, the type here should be user admin. This is equal to, then you can see name is equal to John. Permissions, John has the permissions of read and write. Okay, so now if you try to change these permissions to a number, this will cause an error. Because remember, the permission here is an array of string, and you cannot include a number in an array of strings. That's how helpful TypeScript is. So this type intersection, now the user admin type combines the user and the admin. Then if you specify here permissions as well, let's just copy this. Paste here. Now if you hover over user admin, you see it's a user and admin. So these permissions here, they are combined. Intersection, this and this is, so it will choose one, the name here of the string, and then the permissions here. But this is unnecessary, just remove this. You just want a user. You want to use only this one for a user and then use this one for an admin. But if it's a user admin, just combine the user and the admin. Or you can divide the two. If it's an admin, you combine the user and the admin because you need the name of the admin. But if it's only a user, you only use the user type. You can say something like the user equal to name John, like this. So that is basically intersection. Moving on, we have type aliases. Okay, so we use this type, say type, say user, or you see number is equal to string, like this. Oh, this is a reserved keyword in TypeScript and JavaScript. You can see types user, it's a string like this, and then you can see const name, const n user is equal to code. This basically a kind of explicitly specifying the type. So type aliases provide a way to create like new names for existing types. So they offer several advantages for code readability and maintainability and all of that. So let's assume a user is an object. You can simply say const user. The name is a string, page, the number, and then you You can come here. Then you are having an error here. The string is not assignable to type user. You can just your object and it's a new John. You still have an error here. It's saying age is missing in type because age is required, except you mark it optional. Then it's not required, but if it's not optional, then age here, say 4, like this. And then you have your type. And if you try to add another property, you get an error. So age 2, song. Then you get an error. This error says object literal may only specify non-properties, but age2 does not exist in type user. Did you mean to write age? Because it only recognizes name and age, and you are starting to write age2, so it's assuming you want to write age. Okay, so you just remove this. Okay, so that's type analysis. And then we have the key-off operator. This basically specifies the key-off operator here. In TypeScript, is a powerful tool for working with object types. So it allows you to extract the set of all strings or numeric literal keys from an object. So let's say we have this. Let's change it to an interface. And then remove this. And then here we can see type user keys is equal to key of user. Now, if you hover over this, you can only use the keys. That is the key of user. You want the name and the age here. So basically, anyhow you want to use the user keys, if you want to check object keys, object entry, as you want to validate those, you can use this. You can use this key of to get the keys of this object, the object you want to use it on, and then carry on with what you want to do with it. Okay, so that is basically the key of operator. Moving on, we are done with combining types. We've learned the union types, the intersection types, and type analysis with key of. So moving on, we have type guards and narrowing. The instance of, the type of, the equality, the truthiness, and the type predicates. Okay, so these are basically TypeScript stuffs, and you need to understand the basics so you can be able to understand TypeScript. So the type guards and narrowing are techniques to refine the type of a variable at runtime based on certain conditions. So this helps improve type safety and allows you to access properties or methods that might not be available on the initial broader type. So functions or conditions that check the type of a value at runtime and narrow down its type based on the outcome. Those are the type guards. They check the type of a value at runtime and narrow them down its type on outcome. So the type narrowing, the act of this is the act of refining the type of a variable based on the type guard, or any other conditional check. So basically, an instance of is used, and the type of is also used in type guarding and narrowing. So basically, where you can use an instance of is used on classes or objects. Check if an object is an instance of a class. So basically, you can do something like you can define a class and then create an object from that class, and then check if that object is an instance of that class, and then try to do something with it. And also the type of operator. You can check if the value is a type of another value, then you can get to use something like, it's the same thing as doing, you have a class, like this. This is your class. Let me see const. Then you check if person one is instance. You check if person one is instance of person. Then you see person one dot greet. Let's assume this greet method is on this. Let's say greet. Like this. Now, if this object is an instance of this, then you can just, if you run this code, we have hello, because this person one is an instance of this person. So we can go ahead and use it. And let's assume this person object has its own, let's say it has a name or any other statically typed properties. So we can go ahead and then check and then make use of that effectively. And you can go ahead, there are other checks for the type of, you can write a function, and this function can take in a parameter of name and age. Let's see, function do something. Then you have a parameter that is either a string or a number. Now, what you want to do here is you check if type of P is exactly string. You say log P dot to upper case like this. Else log P dot to fixed to like this. So this is type narrowing and type guarding. First of all, you want to narrow this down. So if it's a number, then just do this thing and don't go ahead doing other things. So you can just call this function here. Something and pass in 2.88888 like this, and then run your code. And here you have 2.89. The second is an approximated to 9. You approximate this 8 and then add it to this one, become 2.89. And the same thing as if you put in a string. Let's say hello, and then okay, run your code. Run your code. You have hello in capital letters because of the code you've written. Console.log this to uppercase. Okay, so this uppercase, log this to uppercase and then this to fixed 2. That is to 2 decimal places. So this is basically type narrowing and then type guarding. So the type predicates, truthfulness, equality, those are simple terms. Let's just jump into typing functions and function overloading. Even though we've already looked at this, let's just take a look at it briefly. And now functions in TypeScript, we've already looked at that. But there are different ways we can go about functions. Especially, I want to talk about overloading. So let's basically look at this special one here. Let's say function, and this function here, it takes in, let's say, get details that takes in a name of string and age of number. And the return type is object. Now, if you try to return something else or return not, you get an error. Here we are getting a function whose declared this must return a value. So it must return name, age, because the return type is of an object. So you must return an object. Now, if you return this, you get an error. String is not assignable to type object. So it must be an object like this. Okay, so that's basically how you type functions, and all the parameters you can pass in rest, and this rest may be an array of strings like this, so that when you call this you can pass the rest parameters, or it can be an array of any arguments. Any argument. We already know what the rest parameter is and how to use it. So this is basically how to type it in TypeScript. So what about function overloading? Function overloading here, let's say we have a function, a concatenate function, concat, that takes in x of number, y of number, and then returns. What this function does is it returns a number. Okay, now this same function here, we want to overload it. This time around, this is a string. It takes in a string and return this. Okay, now for the third time, let's bring down the function, and this time around it should be any. And then return x plus y. Now call your concat function. Okay, so this is function overloading. Now we've overloaded our function, but we'll make sure we've handled the types we want to overload it with. The first one is number. The second, we can concatenate numbers and strings, but we only want to do that with numbers and strings. We don't want to do that with any other values, even though the third one here specifies any. Now, if you try to do that here, look at what we've got. No overload matches this call. Overload one of two. This gave the following error. Argument of type boolean is not assignable to type number. This. Now, if you do away with this, we'll have what we want. Now, if you run this function and you come down here, you have 5 and you have KodeCamp. This is function overloading. Even though we use this function in 2 different ways, we still maintain the types. You cannot just pass in any argument, so you get an error. We want to overload it with a string and a number. So that's basically function overloading and how we can work with functions in TypeScript. Okay. So you can even come here and say, okay, do away with this here. String. You can make this a union. so that this can take in a number or a string, and then return a number or a string. And the same thing if you try to pass in a Boolean, you get an error. And all these errors, argument of type Boolean is not assignable to parameter of type string or number. So this is function overloading in TypeScript. Okay, so that's basically it for today. We've come to the end of today's class, and I guess, and I hope, I don't guess, I hope we'll understand these basics of TypeScript. I will continue on Friday and look in depth in TypeScript. The reason why I'm being fast is because TypeScript is broad, and I want us to understand the basics and at least cover every aspect of TypeScript so that you don't get lost on the way. And then from there, you can widen your research and get to understand the rest of TypeScript. So is there any questions?